of Apollo 13, wishing everybody there nice evening, and we're just about ready to close out our inspection of Aquarius and get back for a pleasant evening at Odyssey. Good night.
It was plagued by bad omens and bad luck from the very beginning.
13, we've got one more item for you when you get a chance. We'd like it to stir up your cryo tanks.
It never really converged to the point where you felt you really had total control of what was going on.
Okay, stand by.
About the time you'd turn the corner, something new'd show up.
Hey, Houston, we've had a problem here.
By the time we came on duty, we were well aware that we had a big problem on our hands.
Can say again, please?
It was life-threatening.
Houston, we've had a problem.
It was not about landing on the moon in the right place. It was about survival.
Maybe bus vulnerable.
Stand by, 13, we're looking at it.
Saturn V building up to 7.6 million pounds of thrust, and it has cleared the tower.
This is Mission Control Houston. We appear to have a good first stage at this point.
Okay, bad up. We're go, flight. Looks good here. Guys, that's a good flight. Okay, Econ, GNC. Looks good, flight. Looks good, flight. Okay, Sergeant. Looks fine.
The crew was Jim Lovell was the commander. Jack Swigert was the command module pilot. Jim I had worked with as a backup crew on Apollo 8. When he flew Apollo 8, I was the backup lunar module pilot on that mission. And then we worked, obviously, as a backup crew for Apollo 11. I backed up Buzz Aldrin on that mission. Jack Swigert, because of a measles threat, replaced Ken Mattingly 2.5 days before launch. So that was something that never happened before or since, I don't think, on a mission.
Flight Dynamics Officer says the trajectory looks good. We show a 1/2 mile in altitude at this time.
We had 4 teams in mission control. We did this from a standpoint of easing the shifting schedule, being able to train for very specialized events during the course of the mission. And then one of us always designated as sort of a lead. And basically the objective of the lead was to address any crises that come up to get your team off the console, and the remaining 3 teams would continue 24/7 support for the mission, as well as picking up a lot of the actions related to the getting the crew back home. I happened to be on console at that time, and we're just right at the very end of our shift. We're preparing for crew sleep period. And one of the last things you do is take a look at the cryogenics and see if you need to stir them up, make them uniform. So you got equalized pressures going into life support system, the fuel cells.
We've got one more item for you when you get a chance. We'd like it to stir up your cryo tanks. In addition, I have shaft and trunnion.
Okay.
For a look at the Comet Bennett if you need it.
Stand by. Hey, Houston, we've had a problem here.
Can say again, please?
Houston, we've had a problem.
Glenn was coming on with his team at that time, reading the log, preparing for handover.
By the time we got to handover, we knew full well that we had to take care of this thing in terms of an emergency. We were handling something that we knew was out of control. And in this case, every team that came on was dealing with a major set of problems.
I assume you've called in your backup ECOMs?
Flight, say again?
Have you called in your backup ECOMs now? See if we can get some more brain power in this
We
thing?
got one here.
Roger.
We had this loud bang, which kind of reverberated with a little echo, because the vehicles we're in were metal vehicles, and it was kind of like you're in a big barrel and they hit on the side with a sledgehammer kind of sound. In the tunnel area, some of the metal was actually crinkling, kind of like you take a Coke can and squeeze it.
a little crinkling, so the two vehicles were moving not together, but a little asymmetric, I think, in roll, and that was causing that stress in the tunnel area.
I went down into the command module and saw that we had lost 2 of our 3 fuel cells, that they develop oxygen. I then looked out the window and saw escaping at a high rate of speed a gaseous oxygen, and it turned out that that oxygen that I was examining was from the second tank, because the explosion occurred on the damaged tank, but that also ruptured the second tank. The first tank just blew the entire side of the spacecraft off.
Here is a bulletin from ABC News. The Apollo 13 spacecraft has had a serious power supply malfunction that could cause the lunar landing mission to be terminated early.
At the moment, the astronauts are continuing to try to isolate their trouble. A late report says the spacecraft now is operating on battery power alone. All unnecessary equipment is being turned off.
Oh, within a couple of minutes when I got to my position, from looking at the instrument panel, 2 meters had the needles on oxygen tank 2 in the bottom, and they were fed by different sensors, which are unlikely to fail at the same time. So I knew we lost tank 2. Without looking at mission rules, I knew that was an abort.
Here in mission control, we're now looking towards an alternate mission, swinging around the moon and using the lunar module power systems.
Although we spent lots and lots of time thinking through all the mission rules, when it really happens, like in this case, we didn't have to open any books to tell us what we had to deal with.
Tell me you from flight. Go ahead, flight. I want you to get some guys figuring out minimum power in the LEM to sustain life.
Since the cryo-oxygen tank blew up, it ruptured the other lines, and we lost all oxygen supply to the fuel cells and the crew module. And the crew module was dying real quickly from lack of power other than the battery, and we didn't want to use the battery because we needed that for entry.
This is Apollo Control at 57 hours 46 minutes ground elapsed time. The black team of flight controllers is now on station in Mission Control Center looking at possible alternate missions, as we have an apparent serious oxygen leak in the cryogenic oxygen in the service module. And now in the process of powering down the command module. Less than 15 minutes remaining of electrical power to the CSM.
The biggest things we had to do in the dying moments of the electrical system in the command module was to transfer the guidance system from the command module to the lunar module. And we only had about 15 minutes to do that, because if we didn't get the guidance system in the lunar module, that meant that we'd have to start all over again to try to get the lunar module guidance system up to speed.
The scheme of going across to the lunar module, still connected with the open tunnel, the lunar module would serve as a sort of lifeboat for the crew of Apollo 13.
And then we started turning on all things, the control systems. We were starting to talk out from the lunar module. And in fact, we were in the lunar module before the ground realized it, and suddenly realized that, oh, they're over there. And then, of course, what they had to say is, we're going to have to get you off the course you're in now to get you back on the free return course.
And this meant that we were no longer on a path that would allow us to be swung around the moon and come back towards the landing spot on the Earth. The controllability of the spacecraft was okay as long as we had our indicators up, because we had practiced that, as I had said. But suddenly, to save power, we shut that down for a while, and we had to control it by only looking at our computer display. And I had never tried that before. I really don't know who had, and it's a very difficult task. And we spent a lot of our first part of our emergency or survival time just learning how to control the spacecraft in this mode.
perisyntheon near the moon, they would use the descent propulsion system of the lunar module for trans-Earth injection burn at about 79 hours 30 minutes ground elapsed time. This would produce a day early entry at about 142 hours. That is a day earlier than a nominal free return entry. We're continuing to monitor the situation and still live on air ground.
No, I think to me the loss of comm was business as usual. Every mission, as you went around the backside of the moon, you had LOS and then AOS, and I didn't have any reason to figure we wouldn't be back in the communication when we came out the other side. I spent a good part of the time with Jack Swigert primarily. Jim wasn't that interested. He'd been to the moon and seen it. We shot a lot of pictures. We had 2 cameras out, and we were shooting pictures like crazy, like tourists.
We are about 70 hours from home, and we think we have the situation in control. We've projected the consumables as I've described, and we have a plan for carrying out the rest of the mission, but there is going to be no relaxation at all as far as that goes from now until splash.
Our first maneuver was to get us back on free return. The second one was to get us home early. The nominal flight time back home was 155 hours if we had done nothing else. But because consumables were critical, and the ground was calculating consumables, and Fred was also doing the back of the envelope type calculation, which he figured if we were lucky we had about 1 hour spare consumables left before we had landed. We had decided, or the ground had decided, to burn at about 2 hours past the moon, at about 79 hours, a maneuver to shorten the time to get home again.
Plus X, Raj. We have ignition, Raj.
13%. Ground confirms ignition.
40%. 40%. Let's get it 40.
Houston copies.
Stable control. Looks good now, fine. Raj.
Attitude looks good at this point.
Roger. FTP. Roger, FTP. Still stable.
After that, the ground was very much concerned with power, and we were too. Command module just slowly kept going down in temperature until I think just prior to reentry, it was down to about 38 degrees. And along with that, it was a sort of a chilling coldness. The walls were perspiring, the windows were completely wet, and it wasn't too healthy. I recall that we went in there to get some hot dogs one day, and it was like reaching into the freezer for the food. One of the potable water lines was frozen the morning of entry on the last day. That's how cold it was in there, without active thermal control. Of course, as the temperature went down, we became concerned about keeping warm, and Fred and I broke out our lunar boots, which we had stowed away in the lunar module, and Jack looked at his wet feet a couple times. But he had an extra set of underwear, so he put that on. We actually had a third little sleep restraint, which Fred then put on and buttoned up and kept a little bit warm.
The command module was very wet. The water separators weren't working, either in the LEM or the command module, and there was water everywhere. In the LEM, there's no inner walls, so you could see water on all the connectors, wire bundles, plumbing, every turn, a glob of water. And the command module, we actually had to get towels out to wipe off the instrument panel to see the instruments.
The carbon dioxide canister was filling up quite rapidly, and we had to figure out a way of using the canisters in the command module and place them in the lunar module systems.
And the ground read us up a procedure in order to adapt some of the command module canisters for use in the LEM. And as they read this thing up, Jim and I constructed one of these things. At this point in time, I think the partial pressure of carbon dioxide was reading about 15 millimeters. And we constructed 2 of these things and put them online, and I think within an hour, the partial pressure of CO2 was down to 0.2. So these were very effective devices.
About the time that we had the lithium hydroxide canisters in place running on the line, my team came in from the rest period. And trajectory team came up. Jerry Bostic was running that. Basically said, I don't know what's going on, but our trajectory's shallowing out. We had to figure out how to perform maneuver without a computer display system, and this was one procedure that they developed, I believe, for Apollo 8.
The ground, after some tracking, realized that we were not on a trajectory that would get us safely back home, and that we'd have to make another maneuver.
We making the burn, and about, I'll give you a hack here at 2 minutes to go.
By this time, the crew stations became a lot different. There are 3 people in the lunar module now, usually built for 2. This last maneuver was going to be unique because we did not have the platform powered up, so we didn't have a normal method of determining the attitude of the spacecraft in order to perform the burn.
Right here, 2 minutes, we got it.
On Apollo 8, some time ago, we were concerned with perhaps losing a platform on the return voyage home, and since no one had ever made a lunar trip before, we were looking at sort of way out ways of determining how we could make these corrections home. And some of our people here at MSC had come up with an idea about using the terminator of the Earth to orient the spacecraft and then the sun position to get orientation and pitch. And with that knowledge, we could then make corrections to correct our angle of entry into the atmosphere.
And mark it, 1 minute.
And as you know, I think that the angle of entry into the atmosphere is a very small angle, only about 2 degrees, and so it has to be controlled very closely, and that's what the main tracking is for. So at 105 hours, they gave us instructions to relight the descent engine, to orient the spacecraft in this manner, and give this particular procedure a try. And when they read up the procedure to us, I just couldn't believe it, because even on Apollo 8, I thought I'd never in all the world have to use something way out as this.
Engine arm to descent.
And because it was a manual burn, we had a 3-man operation. Jack would take care of the time. He'd tell us when to light off the engine, when to stop it. Fred handled the pitch maneuver, I handled the roll maneuver, and I pushed the buttons to start and stop the engines.
Ignition. Thrust looks good. Shut down. 470. Okay, looks good. Nice work. Let's hope it was.
Everything got stacked up to the end. We had a dead mothership. Another big challenge for the ground was to build the procedure in about 3.5 days, how to power it up. We had no procedure to power it up. It had never intended to be ever shut down. And that was a pretty monumental task for a lot of people on the ground.
We've run these simulators both here and at the Cape and at the contractors that continuously ever since last night. We've tried to simulate virtually everything that we've had the crew to do that is non-normal that they've done. And we've proven most everything that we've been able to run on the simulator prior to passing it up to them. There may be some details we haven't done, but at least we've checked the feasibility of everything we've done, and we'll continue to do that.
We really threw away the book. We had never powered down a command module in space, and we had never reactivated one.
And Jack wisely said, well, The first thing was to push in all the circuit breakers with panels on each side. And he said, let's punch in, we'll time it, we'll punch in 6 and stop and see if we smell burning wire, which you can tell when wire's burning. And then we'll step ahead and do the next 6. So we went through the initial activation that way, knowing things were wet. Now, we were, I think, saved in a second-hand way by the Apollo 1 fire, because they rewired totally both vehicles, so everything was virtually waterproof.
Normally when you come home, you have only the command and service module. So the only thing we have to get rid of is this service module just prior to entry of the atmosphere. Coming home now, though, we had a dead service module. We had a command module that had no power to it. We had a lunar module that was a wonderful vehicle to travel home with, but didn't have a heat shield, unfortunately, and shortly we'd have to abandon her.
And Jim and Fred were in the LEM and using the translation controller to give us some velocity, and when Jim yelled fire, I jettisoned the service module. And it went off amidst a lot of debris, which is usual, and Jim began to pitch around to try and photograph it.
We copied that report from Jim Lovell of service module separation at 138 hours, 2 minutes, 8 seconds.
I finally caught sight of the service module as it tumbled around in view. And it was, to me, sort of an amazing sight.
And there's one whole part of that spacecraft missing. Is that right?
I didn't realize that this whole panel by the high gain antenna was blown clean off right along the area where the panel normally swings open. I could see the interior. I couldn't see exactly what was damaged. I could see material hanging out from the interior.
Right by the high gain antenna, the whole panel is blown out, almost from the base to the engine. Copy that. It's really a mess.
So now we have the command module and the lunar module together, which is an unusual combination. We've never flown this before.
Then a little later, with an offset angle, we blew off the LEM, basically. We had to pressurize the tunnel and blow it off to get the separation kick of the LEM. And again, that was done very late.
We couldn't jettison that until we knew for sure that the command module was in the proper place, the proper time, the proper angle. If we came in less, we'd skip out like skipping a stone on water. If we came too high, we'd burn up just like a meteor in the atmosphere.
We're up now on 3 minutes until time of drogue deployment. Standing by for any reports of acquisition. Got a report that a RIA 4 aircraft has acquisition of signal. Odyssey, Houston, standing by, over. Okay, we read you, Jack. That was command module pilot Jack Swigert. We're looking at the weather on TV, and it looks just as advertised, real good. It's been 2 minutes now from time of drogue deployment. A report of 2 good drogues coming up now for main chutes. Odyssey, Houston, we show you on the mains. It really looks great. Extremely loud applause of Apollo 13.
Apollo 13, this is recovery, over.
I recall, Captain, that when I spoke to you on the phone, you said that you regretted that you were unable to complete your mission. I hereby declare that this was a successful mission. From the start, the exploration of space has been hazardous adventure. The voyage of Apollo 13 dramatized its risks. The men of Apollo 13, by their poise and skill under the most intense kind of pressure, epitomized the character that accepts danger and surmounts it.
Once we were into entry, which was incidentally done fully automated, it was pretty much the normal entry all the way down, and all three chutes came out. And kind of miraculously, since we had abused the vehicle, the mothership, by freezing it for 4 days, the water tanks were frozen when they recovered it on board the ship. So we exceeded specifications on all the avionics, certainly. It gave us the second most accurate splashdown of the program.
So it was a question of getting this entire world geared and oriented to one single job: get the crew home. And boy, the teams worked out great.
And it didn't need coaching. It just happened. And we all knew each other. We all were comfortable with who could do what and so on. So there you are. We pulled that off.
Actually, I guess when the parachutes came out and they blossomed and we landed on the water and didn't sink, I think we were home safe.
Well, of course, when we hit the water, we were very happy to be back home, and we commented on that fact. The recovery of 13 was almost textbook recovery. It was a calm day. The actual splashdown itself was very mild, and the Navy did a grand job.
If anything, has increased my confidence in the ability of this nation's space program to take an unusual situation and react to it and come out with a successful conclusion. I consider recovery of the crew a successful conclusion of the... But I have nothing but the utmost admiration for the people on the ground who worked tireless hours to get us back.
Sometime this year, I'll have had 15 years with NASA, and I don't figure I'll retire for another 30 maybe. So I'll just do whatever job the agency decides is the best place I can be and to contribute the most.